All right, let's take a look at question 3. So here we're on some content questions, and this first one is mostly on the particle physics, but also touches on mechanics. So we're going to deal with two things. One is positron emission tomography, PET scans, and the other is going to be about a solar sail. Please excuse the annoying noise from my dishwasher. Hazards of teaching stuff from home. Okay, so question 1, it wants us to explain what's going on in a beta plus decay process. Specifically, it says explain how the change in quark character affects the number of neutrons and the number of protons in the unstable nucleus. So if you're not telling me about the number of neutrons and the number of protons, we aren't getting marks. And if you're not describing the actual quark characters, then we're not getting marks. So make sure we read the question carefully, underline key language or highlight it if that's helpful. So this student here has done a pretty decent job because he said that the proton turns into a neutron. Now that tells me how the number of neutrons and protons have been affected. Perhaps an even clearer way to have done this would have been to say that the number of protons goes down by 1 and the number of neutrons goes up by 1. So there's a mark for that. What the student here has missed though, whilst he has described a little bit about what's going on with quark characters, I can see an up, down, down, which is the quark character of a proton. And here there's also the quark character of the proton. This description is quite confused of what is actually going on there. We need to literally state that an up quark has been changed into a down quark because that's the nature of the proton and that's the nature of the neutron. So in order to change that, the weak nuclear force has converted one of the up quarks into a down quark. And just to be really clear on this, just a little bit of a reminder, what's happening in beta plus decay is a proton is turning into a neutron plus a positron, which I've labelled here as a beta plus particle. And because this is an anti-lepton, we also need to balance that with a lepton. In this case, an electron and neutrino. If we're going to look at the quarks here, we have up, up, down, converted into up, down, down. The charge difference has been carried away by the positron. Okay, so this question I quite liked. Many of you guys did not feel the same way. So we're going to have to come up and use the equation that's provided here, which tells us that the momentum of the photon is equal to photon energy divided by the speed of light in a vacuum. Now this shouldn't be too big a problem for you guys, because the momentum is what we're going to be asked for in this question. The photon energy, well, there's lots of things we can do with that. For example, you know that energy equals hf, or you also have a different version of that if you need to use mass. But you know, we actually turn out not to need any of these. And the speed of the light in a vacuum, 3 times 10 to the 8. So down here, we've been given the energy of each gamma ray photon that's produced. A positron interacts with an electron, resulting in annihilation. So you're going to get two electrons, one electron, one positron, but they are antiparticles of each other, annihilating to form two photons, each with this much energy. So if we want to calculate the momentum, we're just going to take the photon energy and divide it by the speed of light in a vacuum. It really is as simple as that. Now there's one mark here for doing some conversion, because the value that we've got here is in mega electron volts, and this student unfortunately has forgotten to convert that into electron volts. Several of you did convert that but made mistakes in other places instead. So this should be 0.52 times 10 to the 6 electron volts. You then need to get it into standard SI units, so we need to turn it into joules by multiplying it by the charge of an electron. Dividing it by the charge of an electron to get it into joules. Remembering that the value in joules will be a much smaller quantity because a joule is a much larger unit than an electron volt. So there's a mark for doing any of those conversions correctly. Another mistake I sometimes saw was that when you were working out the energy, some people didn't recognize that there were two of these and two photons produced. So essentially it's a 1-to-1 ratio. One of these is going to produce the momentum of one of the photons. So we can actually just use this number, divide it by 3 times 10 to the 8. The student here has a error carried forward mark because there was a small mistake here with calculating the energy, but everything else is done correctly. The answer you should be getting is this number, but times 10 to the minus 22. Okay, so you guys did fantastically on 3.3 and really don't need anything said about that. You will recognise that there were two photons produced and it sort of impacted. It was absorbed over here by the detector. This question, though, produced a fair few errors. Most of you did score marks, but probably not enough. So this student here has identified that two photons are produced, and that's the key thing. Okay, 1 mark for saying that two are produced. The next mark is the idea that they have equal but opposite momentums. Now, the easiest way to get this mark is simply to say momentum is conserved. The other thing you could say is that they have opposite momentum. So one is positive and one is negative. So that's why they go in opposite directions. Unfortunately, just saying that their velocity was opposite or just saying that their directions were opposite was not enough because it doesn't explain why. Okay, so on the next question, we're considering a solar sail, which actually has been done as an experimental spacecraft. And we're given a graph here that's just a simple velocity time graph. Now, the next question asks us to use the velocity time graph to calculate the acceleration in meters per second squared of the solar sail. Now, they're kind of making it a little bit obvious here by reminding you of the unit. I think 2 students have got this one fully right. And I'm sorry to say, guys, but that's totally unacceptable. If we can't work out the acceleration from a velocity time graph yet, we really need to go back and check some of our GCSE skills, because acceleration from a velocity time graph is simply given by the gradient. Now, some of you guys went and used equations of motion instead, or perhaps said that v minus u over t is the acceleration. Now, whilst that is true, we don't actually know that this linear relationship carries on in this part of the graph. We don't have the data to support that. So what you must do is use the gradient of the graph rather than any of the calculations. And there were just tons of little silly mistakes. So for example, not realizing that this isn't 0 on the graph, it's at 0.60. Lots of people just missed that this was in millimeters per second. I even had someone missing that this is in hours. So folks, there are lots of things that can trip you up here, but these must all be standard checks you do in your toolkit. Okay, so what we're being asked to know is that the gradient of this graph will give us the acceleration. We're being asked to spot the units on both axes, and we're being asked to spot that this doesn't go to the origin at 0, 0. So use the entire triangle. You're just going to do your dy, your delta y, by your delta x. So you're going to go from 60 up to 79. Find the difference between those for your delta y. For your delta x, use the whole thing from 0 to 1.2. Now the answer that you should be coming out with is 4.5 times 10 to the minus 6. You can give an extra sig fig if you like. Okay, now loads and loads of students were getting 1 or 0 for that. There's 1 mark for using the gradient, so you're using the change in y over the change in x. And there's 1 mark for the correct answer. Okay. The last question, I thought this was quite an interesting one. The reflectance, so that may be a new term for many people, but they'll do that. They'll chuck in a few new terms here and there. Of the surface is proportional to the percentage of incident photons that are reflected off the surface. Explain the effect of increasing the reflectance of the solar sail on acceleration. So I managed to award a fair few marks on this, but unfortunately this student, whilst having some pretty good ideas, just hasn't quite stated what he needs to state to get any of the marks. So if you increase the reflectance, then the percentage of incident photons reflected increases. That is correct. As there's more reflectance, more photons are reflected as a result. That's also correct. But we need to say, so acceleration will increase. Okay, so we need to state the effect, first of all. Now, by way of explanation, we need to be just a little bit cleverer. For me, I think the easiest way to think about this, we can obviously relate acceleration to force because F equals ma. But we also have another equation on the data sheet, which is that force is the change in momentum per second. So what I would like to say is because more of the photons are reflected off, there will be a greater change in momentum, and this is a tricky bit, per second. Because you'll have a greater change in momentum if you just wait longer. So we must always say greater change in momentum per second. Now there were a few options for this, so I have awarded several marks, but for me, I like this method because I can actually go to the data sheet to give my explanation. It's really important also just to kind of link this. The change in momentum per second means that there is a greater force on the sail, and having a greater force on the sail means that there is a greater acceleration on the sail. So acceleration will increase. Now what I've said there would be enough for 3 marks. Frankly, there are only 2, so we can get the mark for saying that there will be a greater rate of change in momentum. Or a few other options. So have a look at your own paper there, and if you want more tips, take a look at the mark scheme.